Okay, guys, so looking at the chain rule, this is section 2.4 in our book. We have a formula here for the chain rule. It says the derivative with respect to x of f of g of x is equal to f prime of g of x times g prime of x. This is the way our book describes the chain rule, and it's perfectly fine. I found people understand it a little bit better if they think of it like this. d dx, meaning the derivative with respect to x, of k u to the n is going to be equal to k times n, u to the n minus 1, times u prime. This is really just the same rule that we've used over and over again for finding the derivative. The difference is going to be that u is going to be a value that's inside of parentheses. So when we have a coefficient, we have something in a parenthesis, and then we have an exponent. The way we can do the problem is the coefficient times the exponent, then we write whatever the parenthesis value is, we do to the n minus 1, and then times the derivative of whatever's inside that parenthesis. Let me show you how this looks when we actually do it. This is the same problem that we did in our warm-ups by multiplying it out. Now we're going to identify k. K is the coefficient, which is 3. U is just the parenthesis value, so it's going to be 2x plus 1. N is going to be the exponent, and so that's just going to be 2. So now we're going to apply this formula for finding the derivative. So doing that, I'm going to have m prime of x is going to be equal to k times n. So I do k times n, 3 times 2 is 6. Then we write u. U is just my parenthesis value. To the n minus 1. N is 2, so 2 minus 1 is 1. I don't have to write that. And then times u prime. Well, here's the u, and we have to take the derivative of it, which is 2. And then just simplifying this, 6 times 2 is 12 times 2x plus 1. And that's the derivative finding the chain rule. That is the same answer that we got when we multiplied that whole problem out in the warm-ups and then took the derivative that way. Same thing. When we have a problem where it's just the value's just getting squared, it's pretty much just as easy to multiply it all out to find the derivative. But think if this exponent had been to the 3rd or 4th or 5th, or even to the 100th. It would be very, very difficult, it'd be impossible to do that problem by multiplying it out. But with the chain rule, we would still be able to do it. Let's look at the next problem. This problem would have been impossible until we learned the chain rule. We've never done a derivative where we have something inside of a parentheses raised to a power that is fractional. So we have to, again, identify k. K is what's in front of the parentheses, so what is it? U is the parenthesis value. N is the exponent. So now to find our derivative, just following our formula, it's going to be k times n, which is 2/3. Then we put our u, and then we have to do to the n minus 1. What's n minus 1 going to leave us with? Negative 1/3. And then times u prime. So what's u prime going to be? What's the derivative of that, you guys? 16t. So that's all the calculus. Now the algebra comes into play that we have to simplify this. We don't want to have negative exponents. We don't want to have complex fractions. So I have 2 times 16, that's going to be 32t. 3's in the denominator. This is a negative exponent, so to make it a positive exponent, it has to go to the denominator. And we get this. If all of the multiple choice options were in radical form, you would have to recognize that this could also be written this way. So the 1/3 power just means the cube root. Questions on that? That's the chain rule. We have to make sure that the problem is in the correct form in order to use the chain rule. To use the chain rule, we have to have k u to the n. U has to be something in parentheses. So looking at this problem, I need this to be in k u to the n form. It's not right now, it's in radical form. Who can tell me what this would be in the correct form? Casey? Do we agree? Yep, that's correct, isn't it? And so now if you need to, and you certainly don't have to write down k, u, and n, it's just that when you first start doing it, sometimes it's helpful to have it all written out. But just like with the product rule, when we first started doing the product rule, we'd write down f, f prime, g, g prime, but then as we got better with it, it wasn't necessary. This will be the same way. So now to find our derivative then, we're going to do k times n. Negative 2 times 1/3 is negative 2/3. U, and then to the n minus 1. What's n minus 1 going to give us, guys? Negative 2/3 is right. Times the derivative of the u. What's the derivative of the inside of the parentheses there? Negative 3. Okay, now take a minute and simplify that. We don't want to have negative exponents, and we want everything simplified. So hopefully you notice that these 3's would cancel because we have 3 divided by 3. A negative times a negative is just going to give us a positive 2. And then on the bottom we have 4 minus 3x to the positive 2/3. This would be the correct answer if we use rational exponents. If we wanted to write it in radical form, it would be 2 over the cube root of 4 minus 3x squared. Questions? Guys, also with this, I think I told you at the beginning of the year that it's very important that you keep your notes. Right now, from here on out, is where I would make sure that you keep your notes. Most of you started looking at colleges. You may know whether or not you're going to take calculus next year. If you're going to take calculus, you want to have from the chain rule on. I think you could get by without the previous stuff. It wasn't really too difficult. But if you even read your book about the chain rule, it looks very confusing trying to read the calculus book. But if you use this method, it actually is pretty straightforward. All right, looking at example 4. In order to start with the chain rule, we have to have k u to the n. K must just be a constant. That is not a constant. Therefore, I cannot use the chain rule at the very beginning. This is the most common mistake. What people do is they say k is 3x, and then they do k times n, u to the n minus 1, and think they're finished. It won't work. K must be a constant. So instead, since this is a variable, what do you think we're going to have to use at the beginning? Product rule. Product rule. So I have to identify f is 3x. G is 2x to the 3rd plus 1 squared. So I'm going to have to use my product rule. I'm going to have to do f prime. So f prime is 3 times g plus f. Now, when I go to do g prime, to find g prime, I have to use the chain rule on it. See, this is k u to the n. Anytime my u value is inside parentheses, I have to use the chain rule. So to find g prime within the product rule, I have to do 1 times 2, k times n is 2, times u, I'm going to run out of room here, to the n minus 1, which is 1, but then times u prime. And what's u prime going to be? What's the derivative of my u? 6x squared, good. Now I'm just going to rewrite this so we can see it a little better. So I've got 3 times 2x to the third plus 1 squared, plus, I'll just go ahead and multiply this out. 6 times 2 is 12, times 3 is 36, x to the third, times 2x to the third plus 1. There. Now, this is not my final answer, though. I need to have this in factored form. Later on in calculus, we have to be able to set these derivatives equal to 0. Remember how when we would ask, where does it have a horizontal tangent? You'd take that derivative and set it equal to 0. If I set this equal to 0 right now, I can't solve it. It must be factored. Here's my first term. Here's my second term. What do those two terms have as a common factor? What can 3 and 36 both be divided by? Everybody? 3. What can 2x to the third plus 1 squared and 2x to the third plus 1? Well, I can take out a 2x to the third plus 1 to the first. That's my GCF. So now this term has to get divided. So 3 divided by 3 is even. This to the second divided by that to the first is just going to be 2x cubed plus 1 to the first power. You don't even have to put it in parentheses now since it's to the first. And then 36x to the third divided by 3, well, that's just going to be 12x to the third. And then 2x cubed plus 1 divided by 2x cubed plus 1, that's just going to be 1. And so this is what I'm left with. So my final answer for this derivative is 3 times 2x cubed plus 1 times 14x cubed plus 1. And that is in simplified form. So just kind of reviewing again what happened. Because this had an x, this is the same problem as warm-ups, but we put an x in there. That made us have to use the product rule. While we were using the product rule, when we had to find g prime, that requires the chain rule. So we had to use the product rule, f prime g plus f g prime required the chain rule, and then we had to simplify it by using factoring. Questions? All right, so just building on that, let's look at example 5. With example 5, I have parentheses. The way it's written now, my k would be 1, my u would be 4 over 2t minus 5, my n would be 2. I would have to do k times n, u to the n minus 1, times u prime. What's u prime going to require us to use? Quotient rule. We would like to avoid that. If this is a constant, I can avoid it. Here's the reason why. The reason we can avoid that is that we can rewrite this just by kind of multiplying it out. See, this is the same thing as 4 squared, which is 16, over 2t minus 5 squared. I can just write it like that. 4 squared over 2t minus 5 squared. That's equivalent. Remember, if I just want to use the chain rule, I have to get it into ku to the n form. K must be a constant. Can I do that? Can I get this into ku to the n form? Can anyone think of how we can rewrite this? So it's ku to the n. Lizzie? Perfect. That's going to do it, isn't it? Ku to the n. So k is going to be 16. U is going to be 2t minus 5. N is going to be negative 2. And now we can go ahead and apply that chain rule. So we have to do k times n, u to the n minus 1. Negative 2 minus 1 is negative 3. And then we have to do times u prime. Don't forget that. Guys, that's the most common thing, is people forget to do times u prime. So u prime is going to be 2. So now I'm going to have negative 64, and then to make that a positive exponent, it's going to go to the bottom. Now, my last grade class, we didn't think to do that. I just asked them how to do it, and they suggested we do the chain rule and then the quotient rule within the chain rule. I just want to show you how that would look and how we would still get the same answer. So you don't need to write this down, just kind of watch. So here's our problem, and I'm going to just now use the chain rule from the beginning. So if I use chain rule from the beginning, k is 1, u is just this, n is 2. So I would have to do this way. I would do k times n is 2, u, to the n minus 1, which is just 1, and then I would have to do times u prime. Well, here's my u, which requires the quotient rule. F prime is 0 times g minus f, 4, derivative of g is 2, all over g squared. So look what we've got now. We've got 2 times 4, that's 8, times, this is 0, and then 0 minus 8 is going to be times negative 8 there. And then on the bottom, I have 2t minus 5 to the first, and then times 2t minus 5 to the second. So that's going to give me negative 64 over 2t minus 5 to the third. So maybe some of you think that way was easier. The same thing, same answer we got either way. Same thing. Okay? All right, let's go to example 6. Again, you don't want to start just by using the quotient rule. You want to look at this and determine, can you get it into ku to the n form? Try to do that. If you can write it that way, where k is just a constant, u can be in parentheses, n can be any exponent, then you will just have to use the chain rule and not anything else. Any ideas on how we can do that? Yeah, what do you think, Joe?
3 times 2x minus 1 is negative 1/2.
Great, that's right. See, now I don't have to use the quotient rule at all. But let me point out, guys, if this had been an x, or an x squared, or anything else, I wouldn't be able to do this shortcut. I would have to just stick with the quotient rule. But we're lucky. That's a constant. I can do this. So now we're ready to go. So y prime. I'm not going to write out k, u, and n this time. Try to get away from that if you can. If you still need it, go ahead. But let's do k times n. That's negative 3/2. U. Subtract 1. That's negative 3/2. Don't stop there, because what do I have to do? Times 2, right? Times u prime, which is 2. So now I'm going to have 2 divided by 2. Those are going to cancel. And now it's just a matter of rewriting it. No negative exponents, so I'm going to have negative 3 over 2x minus 1 to the positive 3/2. That would be okay. In the back of the book, though, they might write it as negative 3 over the square root of 2x minus 1 to the third. Or they might even do this. If you have the square root of something to the third, that means I have this times this times this under there. As long as I have 2 alike, one could come out and one could stay inside. All of these are correct. This is correct. This is correct. This is correct. Just be aware that all of those are equivalent and all of those are simplified. It's just this is with rational exponents. This is in radical form, but not most simplified radical form, which is there. Questions? All right, one more. What about if we have a trig function? We had some trig functions in the warm-ups, but they were just simple problems. If our trig function is getting raised to a power, it's going to require the chain rule. Because this is the same thing as the secant of x quantity to the third. That's what this means. When you see that 3 there, it means secant x times secant x times secant x. It does not mean x times x times x. It means the whole value of secant x raised to the third power. So I'm going to go back again and use the k-u-n. K is 1. There's nothing there. U is secant x. N is 3. So to find our derivative then, we do k times n. 3 u to the n minus 1 is going to be squared times u prime. You might remember the derivative of secant? Yeah. Good, Michael. Secant tangent. So we're going to have secant tangent. So now what we're going to end up with then is we have secant x times secant x times secant x times tangent x. Well, secant times secant times secant, that's going to give us secant to the third again, tangent x. And that's going to be the derivative. I do want to think ahead that secant is 1 over cosine, tangent sine over cosine. I want to think, would anything cancel? And it wouldn't cancel because all the cosines will be on the bottom. So this is the most simplified answer. But like if this had been cosecant, then it would have been like 1 over sine, and this is sine over cosine, so I could have canceled some things, and I would want to do that. But as it is, it can't be done. So that's it. Any questions? All right, guys, so you have your homework assignment up on the board, on your assignment sheet, on Canvas. I also wrote the first 4 problems out of your book up there. I'd like you to go ahead and try those before you go, and I'll also let you take a look at your quizzes.